Ladies and gentlemen, please be ready as the event will be resuming shortly. Before we begin, here are a few gentle reminders. Firstly, kindly rename yourself according to the username that we have sent to you before if you have not done so. Secondly, please mute your microphones throughout the session unless needed to avoid interruption. Thirdly, we'll be having a short Q&A session later and we'll be using the Mentimeter for our Q&A session. Hence, if you have any questions, kindly type your questions in the Mentimeter and our moderator will bring up your questions later. The Menti code will be sent together with the Menti link later in the chat box. Lastly, we'll be having a photography session at the end of this forum session together with our panelists. Hence, everyone is highly encouraged to turn on your cameras during the photography session later. For your information, we'll be broadcasting this whole session simultaneously on our Facebook page named Regional Chemical Engineering Undergraduate Conference, RCUC. Kindly follow us on our Facebook page by clicking on the link provided in the chat box if you wish to watch it on live broadcast. On behalf of the Organizing Committee Board of RCUC 2022, it is much appreciated if everyone remains with us until the end of the event. Thank you. good evening to everyone. Welcome back, and we are now in the plenary forum session with the theme of roles of engineers in the smart industry. I'm Aaron, and I'm honored to be your MC for this session tonight. I hope you did enjoy your dinner well, and I believe you have been very excited for this forum session. Now, let us get into it. Before we begin, I would like to once again remind everyone that our forum session will be broadcasted on our Facebook page named Regional Chemical Engineering Undergraduate Conference, RCUC, at the same time. Hence, if you wish to watch it on live broadcast, kindly follow our Facebook page by clicking the link provided in the chat box, and don't forget to help us share the live broadcast out to more people. Now, without further ado, allow me to introduce to you our honorable moderator and panelists tonight. Firstly, we have Engineer Dr. Hsion, who is currently an assistant professor in Heriot-Watt University, Malaysia, delivering courses related to process safety and plant design. For your information, Engineer Dr. Lim obtained his master's degree and PhD in chemical engineering from the University of Nottingham, Malaysia. He started his career 10 years ago as a risk and safety consultant, then later to a researcher, and now an academician. He is also an active chartered engineer from IChemE Malaysia. Next, we have Engineer Zulfan Putra, who is currently working as an advanced value chain optimization engineer at ExxonMobil, Business Support Center, Malaysia, Sendirian Berhad. For your information, Engineer Zulfan Putra obtained his Bachelor of Science and Master of Science in 2005 and 2007 respectively, before receiving his professional doctorate in engineering in 2010. He started his career as a process engineer, and he used to be a senior lecturer too in University Technology Petronas, Malaysia. Professionally, he is a practitioner within chemicals and oil and gas industries. Also, we have Ms. Ann Lim Mei Liang, who is currently working as a division marketing manager. For your information, Ms. Ann is a bachelor graduate in chemical engineering, and she used to be a sales engineer in the food and beverage and palm oil industry respectively. Not only does she have a lot of experience as a speaker in various talks and forums, but she was also a winner in the International Sales Progress Contest in 2006. Last but not least, our moderator of the forum, Engineer Dr. Jaga Lakshmi, as the conference chair of RCUC 2022 and a senior lecturer of the Department of Chemical Engineering of University Malaya, who received her bachelor and master in chemical engineering from University Malaya in 2003 and 2007 respectively, before completing her PhD in chemical engineering at Newcastle University, United Kingdom in 2013. Ladies and gentlemen, without further ado, let us invite all panelists to the floor, and I now pass to Engineer Dr. Jaga to moderate this session. Please.
Right, thank you, Aaron. That was a vibrant introduction.
Thank you, right, Dr. Jaga.
Yeah, can you hear me? Yeah.
Yes, Doctor.
All right, that's brilliant. Right, so welcome to all our participants to this forum, and also welcome to Dr. Lim and Miss Ann for sparing your time, which is obviously after office hours, for the benefit of our student. Thank you. Right. So before we are well aware, our topic today is role of engineers in the smart industry. As it is, being an engineer itself, we are being labeled as somewhat smart. I should not unquote. We are smart, right? But then we have a smart industry now that we have to tackle, right? So before we dive in deeper into this area and learn some things from our panelists, let us hear it from them. Let them introduce themselves, about them and how they become an engineer, how was their experience, and what is their present venture that they want to share with us, right? Okay, so we can start with any of the panels who are ready to begin. Would like to go first? Dr. Lim or Miss N?
Okay, I can go first.
All right.
If you don't mind. Okay. So I'll share my screen, yeah.
Okay.
Can you see my PowerPoint?
Yes, clear. You can make it screen if you want. All right.
Okay, so good evening, everyone. It's a pleasure to be here to share our experience and also to be again into this what you call this academic session, because I have graduated 20 plus years. So I've been working in the same industry, which is in the automation industry for 22 years. So I have actually seen the transformation of the industry, before and now. So now there is a lot of rapid changes in the industry when it comes to digitalization. And of course, the roles of engineers today has actually changed a fair bit compared to those days. Yeah. So a bit background about my company. We are a Swiss-based company, Endress+Hauser. We are the people for process automation, and our core expertise is actually in process automation. So I would like to share our experience when it comes to the role of process automation in the smart industries. Yeah. So here, we have this chart. So I would like to explain a little bit on this chart. We have the measuring points at the physical layer. So I'm sure all of you, when you do your study in the university, we have to have measuring points in order to tell us what is happening inside the processes. Okay, so these are the measuring points at the physical layer. So based on our data, actually 90% of the instruments which we deliver out of our company is already digital ready. So somehow they are already smart instrumentation, but somehow when it ends up in the industry, the customer actually only utilize 3% of the data. So the instrument is smart, but the customer is only utilizing this 3%. And what is this 3%? This 3% is actually the primary value. Okay, so for example, if you buy a flow meter, they only takes out the flow meter information. If you buy a temperature, only the temperature information, or the level is only the level information. But the instrument today is smart enough to give you further data. There are more data which they can provide to you, which is remain unused in the instrument itself. So with the help of digitalization, we can actually today connect the data to bring it up into a higher level so that we can utilize this data for better decision making. So first of all, is the connectivity is available. So as you can see from this chart, there are various different ways to connect the data back from the OT layer, which is at the physical layer, to the IT layer, which is at the higher level, which is at the cloud layer. So you can either connect it with wire or wirelessly. So if on this area, on the right hand side, you can connect it wirelessly by using the HART, wireless HART, or this very famous icon, I'm sure you notice it, Bluetooth, okay, Bluetooth. And we even have devices which is battery powered, so there's no requirement of putting power supply to the instrument. So it's battery powered. You don't have to have any wires. You just buy the device, connect it, and then connect it to the cloud, and you can have a virtual twin on the cloud itself. So the technology is there to allow us to bring the data from the physical layer all the way up to the IT layer, so for better decision making. So at the IT layer, which is at the cloud, as you can see here, massive of data is going up into the cloud. So now the question is, what am I supposed to do with all this massive data? So this is where the data analytics and the artificial intelligence, data modeling, this is where they play the role at this level. Okay, so this is already available. Okay, and I like this picture a lot because when I joined the industry, it is more to the picture on the left-hand side, on the left-hand side, where the engineer, in order to access the parameter on the instrument, he has to access it he has to access it via physically. Okay, physically. That means he have to have some sort of connectivity to the instrument. As you can see, he need to disconnect, open up the cover, and plug in some wirings. And also he needs an external device like this in order to read the data out from the instrument. So this is before. Okay, before. And today, if you look at the picture over here, this lady over here, she is having a portable industrial iPad. Okay, she does not need to have access. That means she do not need to like squat down or climb up the ladder if it is installed at height. She can access the instrument wirelessly. Okay, wirelessly, and get much more data than before. So what you can get here today is much more than what you can get here before into the iPad, into the IT layer, we call it, into the IT layer. So the role of engineers is have really changed from the left to the right hand side. Okay. And the other example which I can share with you is, for example, inventory. So in the palm oil industry, for example, you have a lot of palm oil storage tanks, or tanks which store palm oil based products or finished products. And also in the chemical industries, you will have these IBC tanks like the picture over here, where it is being transported by trucks to the factories. So we can have device like this, and this device is actually a radar level device, battery powered, which has GPS embedded inside and SIM card. So when it is transporting, you can actually track the location and also the remaining liquids, okay, how much liquids you have in each of the tank. So this will help in inventory monitoring and also supply chain management. So the supplier of the chemicals know how much the chemicals they have at the customer's place and can actually replenish or top up the stock in time for the customer to use. Okay. So this is how it looks like in the dashboard. So connectivity is anywhere, anytime you can get accurate data. Okay, those days, even until today, in some of the industry like the general industry or the palm oil industry, customer used to climb up to the tank to have physical measurement, or they have those very mechanical measurement. If you look at the reservoir, they have a ruler to indicate how much. So you have to be physically there, but tomorrow you do not need to be physically there. You can connect all the tanks owned by you in various geographical locations, and with one glance, you have total insight of what you have for inventory. So this is very important for decision making and supply chain management. Yeah. So these are some of the examples which I can give. Of course, there are much more examples. Maybe later during the talk, I can share some other experience or example as well. Yeah. Thank you.
Wow, that was interesting, Miss Anne. Yeah, it's actually something I think the students will benefit from. That it's all in your fingertips now.
Yes.
In the clouds. Right. So we welcome IR Zulfan on board as well. Hi, IR Zulfan.
Hi. Good evening.
Yeah. Good evening. So we have just started. So we are introducing our panels. So they are introducing themselves and sharing with us what they do. And related to our title today. So we have just done with Miss Anne. So shall we move on to Dr. Edwin Lim first, and then we'll come to you, IR Zulfan. Right, over to you, Dr. Lim.
Okay. First of all, thanks again for the organizer to invite me, and this is actually a very good event, especially for the students. Okay, to learn about Industrial 4 or the smart industry, okay, from the industrial perspective, and also me being, I would say, only panelist from academic. I hope that I will play a role in terms of this from the giving some opinion from the academic or industrial or this education point of view, and also some research. Okay, so basically, when I explore this Industrial 4 or the smart industries, when I started to venture into this research area, okay, it's quite difficult for me because imagine like me, we studied traditional or the core chemical engineering program in my undergraduate, master, and then I continue in my PhD. Most of this topic or the courses that we learn actually doesn't touch much. It doesn't mention many a lot of things about this IR4. It's quite a new thing. Okay? So in the beginning, I was quite struggled to see what actually I can do to venture into this new topic. Okay, here basically I try to share some of my recent work to see how I would say not traditional, not a good way, but it's traditional kind of chemical engineers or researchers venture into these IR4 things. Now, from the introduction of the MC, previously I get involved in some of these risk and safety or the safety assessment part of this work. So in the beginning, I just think since I'm not sure or doesn't know too much about IR4, why not we do an assessment? And what I do is I just apply what the hazard safety assessment approach. Okay? Basically, in this case, one of my work is I adopt basically the hazard approach to systematically review what are the gaps actually that we can implement this IR4 technology, in this case, in the palm oil industry. Okay? So I do a typical hazard, like treat it as a process to identify what are the potential problems. Okay? Here we can see that across the field study, some of these IR4 or smart industry terminologies start to pop up. Okay? For example, cloud computing, traceability, Internet of Things, and etc. So from there, okay, we can link our traditional approach to see what are the things that we can address, okay, in terms of implementation of this smart industry. Okay. Then furthermore, okay, I also work on this process optimization, where typically I use this mathematical modeling as tools to determine what is optimum or what's the best solution. Here, we also can use a similar approach that we can do some basically evaluation. Okay, in this case, we're looking at something like tools to determine what is the optimum pathway that a palm oil farmers can use to use in this harvesting or evacuation process. Okay, basically, what it means here is that each of these dots represent tree that they have or that we have in the plantation site. Okay? Depending if the tree that has a fruit that ready to be harvested or not, we can use this kind of smart tools or the modeling system to basically come up with a routing map or basically a GPS that might use in the palm oil industry or palm oil plantation site instead of the road. Okay? So this is something that we also can explore as a chemical engineers or as a education or this academics. Okay? Another things that I would like to share is, apart looking at all this potential application, okay, we also, as a chemical engineer, we always look at system. We evaluate what the system performance, etc. So we can do the similar things. Okay? For example, we can evaluate how sustainable is the industrial 4 technology. Okay? What we can do is perform the comparison, okay, a systematic comparison in terms of ROI. I believe everyone knows this, that we learn all these things in the plant design, for example. Okay? We have the technology or we have the capability to do that, but we need to systematically identify what are the CAPEX, what are the OPEX, for example. Okay? Then we can do some comparison between the IR4 technology like drone and also compare with the current practice like tractor or the next step. In this case is for the site application, again in the plantation site. Okay? But this is something that I believe as chemical engineers have the strength to do it, and this is our advantage of being a process engineer, and we can contribute on how we can contribute in terms of this industry. Thanks.
Right. Thank you, Dr. Lim. So this grid, right? This grid you're talking about. So you have the other slide, the third one, right? So you have different colors. So each of these can actually fit into your ROI, carbon footprint, and exposure time. Is it? You found the common ground for it.
Yeah, so basically we evaluate the same thing, we do the comparison, but the data here is actually normalized. So we're comparing the best and the worst. And then, for example, like the highest, number one, meaning this green color one, okay? This has the highest ROI among these 5 technologies. And then for those that score 0 is those that has a worst. And then the between one is we will know, okay? For example, compare T2 and T1, okay? How does this T1 is how much better compared to T2 technology, first technology, second technology. We do a comparison. This is just a comparison chart.
Okay, it's not to prove which is better or not to. I mean, you can improve, but this is to show, how each one differs. Okay, that's interesting.
Yeah, and we also can determine the overall. Actually, we also can calculate the overall in terms of these 3, assuming that these 3 contribute to the same big page. So what will be the overall score? In this particular case, T2 actually is the best option in terms of overall.
Because it has a good, optimized everything.
Yes.
Okay, right. So yeah, because the viewers, when they're students, they don't see what this triangle actually means, right? So that's why I thought I should ask more. Right, okay. Right, thank you. So that's interesting. So it looks like you're applying IR 4.0 into safety.
Yes.
Right.
More to say that I use a safety approach to evaluate the potential of IR4. Because me, myself, coming from a safety background, I can't straight away go into the IR4. I don't have the knowledge to do that. So I try to slowly, adapt. I know, and then slowly move towards that.
All right. Okay, thank you. So those 2 speakers has already informed us how they are already staying afloat in the smart industry. Okay, right. Let's hear it from IR Zulfan. So what are your experiences, what you do related to this smart industry? Over to you, IR Zulfan.
Okay, good evening for Dr. Lim, Miss Anne, and Dr. Jega. Thanks for inviting me here. Well, my role, I've been working in several companies, and then for the past like 5 years or so, or more than that, I've been working. I mean, my job descriptions would be around if we have like a plan, for example, and then these plans are running, and then we have our process simulation model, and then we use that process simulation model to make what we call nowadays like a digital twin of that particular plant. Well, in chemical engineering, we can simply say the process flow sheet. It's nothing fancy. And then we use this process flow sheet to do all kinds of things. For example, we do like a sensitivity analysis to improve the performance of the plants, so that we can advise engineers on the field what to do, which valves to open, how much is then the pressure, how much then temperature, flow rates, and so on and so forth. And we could also do like using the same process flow sheet for optimization. We could also deploy this process simulation software on the site. So depending on the license that we have, how easy it is to deploy on the site, we could do so as well. But on the alternative side, we typically have, like, for example, we make like what we call approximation model, or we make like a regression model, so to say. So this regression model from that process flow sheet, we run a couple of simulations, and then we get the data, and then from that data we make a regression models, and then this regression model we can then deploy on the site. That's one thing. And then another thing as well, for unit operations, or for processes that we cannot really model from the first principle point of view, we use the plant data and then make what we call also like a regression model, or all kinds of machine learning techniques, and then we then make from that model we also deploy and then we use the model to analyze when can we change a certain the catalyst, or when can we do a certain maintenance on a heat exchanger. So we use that kind of approach, which I think quite relevant in the theme that we are discussing about right now. And it's also interesting that Dr. Lim mentioned about that the picking up of the palm fruits, right? It's basically one of the basic supply chain problems. We also have a kind of like mathematical optimization where we model certain things. Well, we call it process system engineering field, but it's also very relevant nowadays. So we from the processes of a system, we make like a mathematical model, and then from that mathematical model, we can either increase or maximize the profit or minimize the resources that we use, in such a way that we can then make the process or system much better or much more efficient than it is now. So that's basically, I think, what I've been doing, I'm busy with for the last 5 years or so.
Right. Okay. Thank you, IR Zulfan. So it's more like you do modeling, and then you match it with the plant, and then you address the model plant mismatches, correct?
Yes.
Okay. Okay.
Exactly.
Yeah, that is something the students I think should be exposed to as well. So we can model a process, we can model an industry, we can model an equipment as well. But once we put it in real, when we connect it to a real pipelines and all, there'll be a mismatch with the calculations. And then how to adjust it in order to fit to what we want the equipment to do is the model plant mismatch. And that comes with experiences as well as some calculated adjustments, right?
Yes.
Okay. All right. So that's brilliant. So we've got all these panels who are directly working in smart industries. So smart meaning, I think, all industries are falling into this smart category, wherein we are trying to follow IR 4.0. Everything is about automation, numbers, figures, and mathematical models. So you have to brush up the maths, and then if you're an engineering student, so maths is you must have got the maths ability. So that puts you at the front line opportunities. All right. Okay. So let's see if we have any questions from the floor. So we haven't got any questions. So I have got some list of questions, some suggested by the speaker as well. So maybe it's from one of you, which I find it interesting. There are some from the students as well. So I think I will go to the speakers one first. Anyone can reply. So with the rapid development of the smart industry, what are the industry expectations from the young engineers in regards to Industry 4.0 knowledge and skill? So what is expected from the young engineers for IR to face this smart industry, to step into this smart industry in terms of knowledge and skill? So anyone can pick up the question and share your notion.
Okay, maybe from me first. Actually, in today's world, in the digitalized world, of course, digital literacy is very important. So the engineers actually must know how to make use of digital technology to bring the information up, like what I've explained just now, to bring the information all the way up to the IT layer for analysis or for modeling, like what is mentioned by engineers Zulfan just now. So this is very important for us to master. So a lot of the industry today in Malaysia, if you ask me, is still under the industry revolution of maybe 2 to 3. So we are not even near 4 yet. Some is even in the terms of 2 to 3. Maybe oil and gas is a different story, because just now I heard about modeling and all this. But in most industry, if we look into palm oil, there is a series of just now, Dr. Lim already showed. We have the mills, the refineries, the oleo, the biodiesel, the whole chain of the palm oil processes. If you look at the mills, I would say it's still at maybe 2 to 3. Some of it is semi-auto, and even though if we put automation in, the engineers or the mill, they do not have the skilled engineers to actually handle the automation. And what happened, based on my experience, is that it will be bypassed or removed. So they will fall back. The mill is built with state of the art. You know, they have this SCADA control and everything for process automation. But at the end, if they cannot get skilled worker over there, then they will try to go back to the previous method. Then they will base on how to bypass it and do it on a manual basis. You know, even today, we need qualified people in the mill, for example, to look at it visually, to look at it by visual and also by experience. You know, by looking or hearing at the sound, they know what is happening in the pipe, for example, this kind of level. So in order to move forward, I think the young engineers really have to be the subject matter expert, and also to learn how to make use of data to get what is the desired output, okay, in terms of productivity or process optimization. So the low skill jobs, to me, will be replaced by digitalization, the low skill jobs. So if your job is routine, if there is a logic behind your job, you know, if someone can do a if else, if this do this, else do this, and then you'll be replaced very fast. So for engineers, I would say that you have to have a lot of critical thinking, intelligence, and a lot of problem solving into very complex problem in future, because the simple problem will be taken care by all the mathematical modeling and AI. So this is the skills or the expectation out of the engineers to me.
All right, thank you, well said. So if you keep being the if else and everything is noted off, no. So no more running away from codings, no more running away from process control. No, okay, yeah, I think that's very well said. So it's important to retain the uniqueness. So we are not going to be replaced by robots in future. No. It's not very soon. It's not happening. It's not happening. Yeah, okay. Which means we still need the brains. We still need people there, right? But the skill has to be in a higher level. Yeah. All right. All right. So I have Dr. Lim. Would you like to add?
I have to confess that this question is actually coming from me.
I suspected.
Because I think this is addressed to the industry. Says that I do have this concern. Like, for example, the recent graduate from chemicals engineering program. Okay, just now I also kind of highlighted that there's a lot of the core chemical engineering topic that in undergraduate we can't actually escape. Okay, meaning fundamental is fundamental. We have to teach them. And with the rapid development, I also have a kind of like a problem, like if we are going to introduce new things into the program, but by right mass balance, we should remove something, but a lot of things are fundamental. So it is quite difficult from the economic point of view to continuously or to keep up with changes. So that's why, like, when it comes to students graduate, fresh graduate students, and industry are looking at industrial 4, the students will not have the capability that they readily straight away apply industrial 4 things into their job. Even for engineers that works for a few years, or sometimes they might also do not have the capability to do so. So this is something that kind of like concern me. I also perhaps before we go continue, engineers, Zulfan, do you have any things to assist? No, you're coming from the industrial side.
Yeah. So we are both from academics, so we have the same concern. So it'd be good to hear from you.
Okay, excellent. Excellent question. Which is also very relevant. I will add that a little bit from what Ms. Anne has said perfectly. Yeah. Indeed, we need to upscale. We need to increase the skill of the engineers, because it happens. While it happens still, the automation in the system, in the plants, one of the plants that we have here in Malaysia, it was put, or it was operated in manual mode. So all the automatic control systems were like set to off, and then the operators were just like running it like whatever they like it. So that was then one of the case that we encountered, and then we had to show them even how to calculate overall heat transfer coefficients, for example, showing them what is then the effect of fouling. How can we see that from the temperature readings, and then can we make a plot, and then can we know when we have to do some maintenance on the heat exchangers in that particular case. So I would like to mention that example. Now coming back to the concerns from the academia, yes, indeed. I think I had a teaching experience, yeah, about 3.5 years at UTP before from 2016 until 2019, just before the pandemic. And indeed, at the time as well, we were struggling on how to cope with that changes, because I agree that our curriculum, the conventional curriculum of chemical engineering, they are already like too packed. And then I don't think we can add more courses or additional courses on that without really like adding more credit hours into it, which we cannot do basically. So what I see, and then what we've tried at that time, we tried. We learned also from other universities as well, yeah, overseas. So what they did, which I think what they've been doing, which I think is also good for us to copy and adjust, is that in most of the chemical engineering courses that they have, they include like a coding and then process simulation exercises. So for example, we have a mass balance course, right? In the mass balance course, we could once we introduce the concept on how to calculate the mass balance and then how to calculate the recycle flow rate, how much purge that we can allow, and then we could also include the how to do that calculation in using process flow sheet, for example, using software like HYSYS or Symmetry or Aspen Plus, and then the students can then relate their manual calculations with the calculations done by the software. Then they know they would then know how to do that simulation. So that's one approach. And then the second approach is that they introduced as well coding at the early stage. So in all classes, say for example, they have like 5 questions for exams. And then one of the question has to be solved with writing the algorithms, so like coding. So if they learn, like for example, Python nowadays, they introduce Python class like a year 1 or year 2, and then they will then try to solve mass balance, energy balance, and then fluid mechanics and so on and so forth by simple. I mean, it's just like a simple calculations. It doesn't need to be complicated, but then the point is that they need to be really familiarized with how the codings work, how we program things, how we solve things using process simulation. Just very simple things, just a matter of like doing things, doing different things, right? I mean, it's different topics, but we do this like throughout the 4 years of the programs, and then by the end of those 4 years, they should then hopefully be able to use process flow sheeting in a much more fluently, as well as programming is also in much more fluently. So that's what I think what we could do in that sense, yeah. And especially nowadays as well, I think I need to emphasize this as well to the students. We have, I don't know how many students we have on the chat. Nowadays is because it's all of these excellent lecturing materials, super lecturers, they are all at the tip of our fingers. So we could easily go online to all kinds of Coursera, Udemy, and many of these are free. So I keep telling to them, don't wait for your lecturers to tell you what to do, because we are all human beings, right? I mean, we have limitations. And then if we have like a spare time, just go out there and then Google some stuff, YouTube some stuff, to see if there's a certain things that lecturers, I mean, forgot to mention or not so clearly explain. We could then just add another 5, 10, 15 minutes to that, to search what is enthalpy is all about, what is entropy, and then what is heat integration. Those kinds of things we could easily find and then quickly understand, I would say. So that's that's for the students. So that's for the students, and for us is that to include this programming and then the flow sheeting techniques into the courses.
Right. Okay. Thank you, Zulfan. So looks like it is proactiveness on the students' side to pick up on the necessary coding
Skills,
and software knowledge, as well as he's saying that curriculum should support the students as well. So when we come to curriculum, it's true. You see, the lecturers are there, and then they are of different level of experiences. So the new lecturers are probably more exposed to softwares, computers, modelings, and all. So to expect every lecturer to be able to cater that to you will be a bit difficult and burdensome. Like how Zulfan said, we are all human and we have our limitations.
Yes. It takes two to tango, yeah. It takes two to tango.
Exactly. So when the lecture, but with the new curriculum review, we review curriculums just for the students' knowledge, right? The curriculum doesn't stay the same. So every 3 to 5 years, we actually revise the curriculum. We add in what are newer, what should I say, topics or newer trends in the industry. We actually incorporate into our subjects. So now the current, the recent review, we have added in IR 4.0 elements. So every subject will have something that touches the part. So with only 14 weeks to go, we only have very small time. So like how Dr. Lim actually mentioned, right? Being a chemical engineer, we can't run away from theory. We can't run away from giving you the fundamentals of it. And the fundamentals of it are not yet IR 4.0, but the IR 4.4 stems from the fundamental. Okay, so we actually convert the fundamental into the mathematical model, so you still need the knowledge. So we cannot entirely depend on the university classrooms to actually make you code. So it takes your effort to actually learn as well with the pre-West and make yourself be more competent with your fellow friends.
Yes.
Right. So I think that summarizes somewhat.
Excellent.
Right. Okay. Then we have another Miss Hannah has mentioned. Yeah, all of you have said something, right? Right. Actually, we have another question. I also think this is also from Dr. Lim, because this definitely sounds academic, but it will be interesting to know answers. Are there any examples where chemical engineers can use the mathematical formula learned from the syllabus to solve the problems related to IR 4.0? So I think this is something we want to share with our students as well. Like they keep blaming, right? We learn so many, equations, theories. Are we really using it? Not everyone is using it. So maybe someone, I mean, it should be from the industry. I'm pretty sure it's your question, Dr. Lim, is it?
No, this is not from me, actually.
This is not from you. Okay, all right. Oh, I thought it is. So maybe, yeah, if you can give, even Dr. Lim, if any one of you can give an input to this. But I can start first, right? Actually, I got my RR, if you can see. So for the students, IR means it's a professional engineer title. So you have to have some industrial experience in order to obtain that. So one of my industrial experience was I was a consultant for in designing wastewater treatment plants. So when I was designing water treatment plants, I was referring to the same textbook that I used in university. So for me, it was useful. Right. Okay. So Dr. Lim, you wanted to say something?
Oh, yeah, I just like to maybe address the questions regarding using mathematical formulas to tackle IR4 problems. Now, from my end, because my research area is on the process optimization and also modeling, so a lot of time we actually use, like you mentioned earlier, the fundamentals, the equations, or go back to basics, mass balance. I always use mass balance to do my model. Whatever in have to same as will come out. So that's the fundamental, the easiest to understand. So those are the things that actually we use. Like just now I mentioned like ROI. Okay, it's not like core engineering mathematics, but there is a mathematics to follow how to calculate our return on investment. Okay, and etc. So those are the things that we can't escape to use to tackle this IR4. But go back to the question is like, do we actually kind of like address specifically these equations or formulas that is indicated for IR4? For most of the case, I would say we don't say that no, this is for IR4, and then we use another equation which is for IR3, etc. We usually don't kind of like do that unless it's assignment specific things or etc. But these are the things that we have to know that we teach the fundamentals. How the user or the engineers use it is depends on the engineers or the students actually. So a lot of time, like the students here, a lot of times we teach in lecture, we teach in our tutorial, but the final exam will never be the same or exactly same like tutorial. So this is the same thing. We teach you the equations. How to apply the equation is actually go back to the engineers or the students. Yeah. So this is something that the students understand the fundamental, need to be creative a little bit and try to solve problem with whatever knowledge that you have. Then as you go, then you get more knowledge, you can solve something that's more complex or in more creative, etc. So yeah, that's my take on that.
Yeah, that's a very important point. Yeah. So again, it is back to the students. We are providing you the basics, the theory. It's how you take in and then you decide to make use. Because like IR 4.0, a lot of this, like the triangles, the connectivities you do are your findings. Is how you decide to use this theory and convert it to the IR 4.0 decision making tool. Right. Okay. Interesting. Right. Okay. So Miss Lim, Miss Anne, sorry.
So for me, actually, I'm not the key expert when it comes to mathematical modeling, actually. So, but what I can share is that, in the design of an instrument, our factory actually has already embedded all the calculations into the meters. So the meters are smart, and what the engineers get is actually the output of the meters, output from the meters. But what we can make use is that from those output, we can actually derive some process insights. So for example, you can actually know whether if there is corrosion or abrasion in the processes by analyzing certain parameters output from those instrumentation itself. So from there, the engineers can actually make a decision when he wants to do preventive maintenance instead of what do you call this? Unplanned shutdown. Yeah, he can actually do predictive maintenance. He can actually do predictive or preventive maintenance instead of sudden plant shutdown due to failure. So these are the things which the engineers can actually make use based on the output from the instruments itself. Then of course the basic knowledge about mathematical function, like what Dr. Lim already mentioned, the ROI, the mass balance. So just now, beginning, I have shown an inventory kind of the last slide, the inventory. So inventory in supply chain is also about mass balance, how much I produce, how much is being charged out, and how much I have in stock. So the whole thing is actually it's linked to mass balance and also plant efficiency, for example. So all this, or energy balance, for example. So now a lot of customers is looking into energy balance, energy reduction, and also moving towards green energy, energy reduction, and also environmental friendly. So all these, the students, there is mathematical formula involved inside. And of course, when we talk about the using software or analysis, because just now it was mentioned by engineer Zulfan, the simulation models, and so I remember we have to remember that software is actually helping us in a way, but as an engineer, we need to understand the output from the software, because I remember last time when I was studying in uni, the professor says this, rubbish in, rubbish out. You need to understand as an engineer what you put into the software, and then the output from the software, the mathematical calculation, whether it makes sense or not. Okay, if I change, or if I want to have this desired output, I need to change this parameter, and then then you must know which parameter to change. It is not try and error, just tembak and put in your parameters and expect your output at the end. You, as an engineer, you must know this is my desired output, and with my desired output, I need to tweak these 2 parameters, for example, and then let the software do a more precise calculation. But as an engineer, we must know what we are doing. This is based on my experience. Yeah,
that's a very good input, Miss Anne. So you don't just tembak the changes, you actually make informed decision. So
correct.
Only with the theory you are able to define that if I make changes to the let's say temperature, so how it will affect my product, will it deteriorate?
Correct.
So I can't do too much of it, and I probably have to change in the blade, in the spinning or some sort of that.
Yes.
Okay.
So this is also back to academics. So what the academic teach, the basic is actually very important. Yeah, very, very important. The IR 4.0 is just assisting us in the decision making, backed up by a lot of data. But then the basic fundamentals still play a very important role. That will not go away. Yeah.
This is actually a take home for you, dear viewers, dear students. This is actually a take home for you. So when a lot of papers, newspapers can actually report universities are outdated, they give you, they don't prepare you for the industry. No, we are preparing the fundamentals for you in order to face the industry confidently. So here, before we hear it from IR Zulfan, right, because Ms. Lim mentioned this, I just want to share an experience. I had a final year student who finished, in 3rd year, she finished her industrial attachment. And then in final year, we usually do exit survey to see how they found our teaching and what can be improved and all. So the question she asked me was that, Doctor, I was attached to an industry where they work on some process. She was in the process plant. And if there's any problem in the process plant or the equipment, we just contact the engineer in Germany and they will solve it for us. So why should I struggle and spend 4 years studying the theories, the difficult equations that you teach us, and why should I learn all that? I just have to, pass the problem to them and they'll solve it to me. So this really shocked me. This is actually a mentality of a 4th year student, but now she's doing well. She's working overseas. She's in the process. If she remembers this question, she'll probably laugh at herself. Okay. So this is the mentality you carry. So forever you plan to depend on the Germans to solve the problem for you. So if you don't have these fundamentals, you are forever going to depend on someone. We are not going to be able to create and run our own problems, right? So that's why your theory and fundamentals, even if your textbook is like still Synod, Coulson Richardson, which was like 20 years ago. We all know Coulson Richardson. We all know Paris. So it can be 20 years ago, but the fundamentals we are teaching you is a necessity. Right, so IR Zulfan, you want to add something on this?
Okay, well, if you ask me, are there any examples? I can give you weeks of examples. I want to just emphasize what Miss Anne and then the others has mentioned as well. This quote on garbage in, garbage out. I would like to add my my professor's quotes at the time, like 10 decades, 15 years ago. So when we did this modeling, so at the time we had a project on to design a control system for a batch reactor. So it was like a existing batch reactor, and then he mentioned that when we this expectation, right? Mr. Anne mentioned these expectations. He refers to that expectation as a mental model. So we said that before you build any model, you have to have like an expectation. You have to have your mental model. And then you make your model and then add the data and then see if it matches the reality. So if it doesn't match the reality, so it means there are 2 things wrong. Number 1 is that your model is wrong, right? The way we write the phenomena is wrong. Or number 2, you are mentally wrong. So that's what he said, which is, that quote really struck me. So we have to have this expectation. So how do we get expectations? Then by getting the fundamentals right, yeah, by getting the fundamentals correct. And I think like about in 2018, 2019, I had a project in a plant. It was like a very manual plant. So we discussed on the what the problem really was, and then I was leading the root cause analysis. And then what happened at the time, by simply making like a simple block diagram, and then we add numbers into it, right? So if we have like 1 tons of raw materials coming in, and then it's being separated here and there, how much is going up, how much is going down to the left, to the right. And then at the end of that session, we found out that the ammonia, one of the components, they are like going through the cooling tower system, and it goes through the wastewater treatment system. And then they just realized that, so we are losing these tons of ammonia into the surrounding area. No wonder whenever then we walked past by the cooling tower, it smells so ammonia. But they just didn't realize that before we put these numbers on the table. So that shows also as one example the requirement of having a good fundamental. In this case, it's a simple mass balance calculations. Yeah, so things that we can write on a piece of paper as well. So that's one example on the mass balance, and then we can see where things are going from where to where, and what are the components that are missing. So we could see that from easy calculation. Another example as well is also this mathematical formula that we learned at the school. It also depends whether or not we use it depending on where we work. And the comments of your student, yeah, Dr. Jega, it has some truth in it. It has some truth in it, and I've seen it over and over again. It's simply because we in Southeast Asia, or in Asian region, I mean Southeast Asia, where we belong, we don't have companies with strong R&D departments. So if we so that we are accustomed to, we have this like how do you call it? Yeah, we have this like historical custom to simply call the licensors whenever there is a problem, and then this attitude is then like yeah, descending down. Then these new engineers just learn the same tactic that they learn from the supervisor or the senior, simply call. And this is, I think, this simply call attitude is then the one that's going to be replaced by the robots, because well, we could simply program this, right? If then else, call licensor. So we don't need you. So so they will be gone. So but my point is that if we work in if we have like a strong R&D, that means we have our own technologies. That means we can then fully utilize the resources that we have in the Southeast Asian region, our own resources. Yeah. So that's number one. And also all the equations that we learn at school, if we work in this R&D, or if we work in the engineering department, for example, we will surely use them. For example, if we go to the plant, so these students, they go to internship, they will then find all kinds of pipes with different diameters, and then I can ask them simply, using your fluid mechanics formula, what is then the typical flow rate that runs into different type of pipes. So I'm giving this homework to the students now. Now go to bed, think about that, and then tell your lecturer what is then the typical flow rate for each of the pipe size, which is simply, I mean, we could simply calculate that from a fluid mechanics point of view. Yeah, I mean, it's not rocket science. So we know. That's why also I think our like all engineers in the past, they don't use process simulation software. They don't use any software, but they build plants that are still standing strong nowadays. It's only like a piece of paper, and then indeed by touching on the surface of the vessel or the pipe, they could then sense is it like what kind of fluid, and then how is then the velocity. So they know that by heart. So that's what I think the skill that we also need to have, especially nowadays. The technologies, yes, technologies can help us, but somehow it's like overrated, I would say. I mean, it's more like we are too dependent on the technology. So in such a way that without a computer or without a laptop, when we go to the field, we cannot even solve the problem anymore. So there's also like a downside that I see in the young engineers. So something that we have to think about.
Yeah, true. Yeah, actually, because they are the digital society, so everything is in the touch of a button. So we are from both. We have seen both of it, so we know even without it, we can still work with spanners and hammers. Right. So that's really an interesting sharing. In fact, that reminds me of a sharing by one of our alumni. He's IChemE. He serves a lot to our University Malaya. So he shared with us how when he was in school, school means engineering, and then they were in their residential college. So the friend was boiling his water, and he just posed a question to him: how long, at what time will this water boil?
Yeah.
So he was the chemical engineering student. So again, like I have Zulfan, the question's back to you.
Yeah.
You do, right? The students.
Exactly.
So you have learned, the boiling points is MCP theta.
Right.
And the MCP theta. And then he said 10 minutes, this water will boil. And yes, it boiled in 10 minutes. So that's how you put it into use. So it's entirely up to you, rather than blaming that, oh, I don't use it. Maybe you forgot. We have already done that to you. Right? Okay. Right. So
if I may add, I mean, it's just like it's like a relaxing talk, right? I mean, if I may add, I think I don't know if any of the students they watch this. Do they watch this like a Indian movie called Three Idiots? I don't know if you know any of these. Any of you know this movie?
You can just put
Three Idiots. So just go watch these movies, and then you will understand what we are discussing now.
So actually, to summarize these Three Idiot movies, one guy, he believes in the theory, but he defines the fact that you only memorize the book and then you get your certificate. In fact, whatever he learns, he puts it into action. And at one point, he will save a woman who's supposed to go into labor. So he'll put all he's I think mechanical or electrical engineer, I can't remember. So he put all his knowledge into it, and then he'll come up with a device. So it's actually a very interesting movie.
Yeah.
You find it in Hindi, in Tamil, and then they have their translation as well.
Right.
Right. Okay. Interesting. Right. So I want to open the session to the floor because it's about 8:30, 1.5 hours. No, 1 hour down. We have another half hour to go. So I do have a list of questions, but I really want to hear it from the floor. So please post your questions, or you can open your mic to ask questions. So I have one question here for Miss Anne. Right, from our Oscar, right? Okay, so this is from PopSIC team. So if you know Pop, they are our IChemE teams, and they are actually sponsoring some of our students. They're actually sponsoring the games. So for students who are watching, and then they have this pop quiz, and then they're sponsoring the prize money for them, right? Thank you, Oscar. So his question is, Miss N, can you comment on the use of IR4 technology in water industry? Use the same technology you presented, Natilian, also. So he wants to know more of Natilian.
Okay. So when it comes to the water industry, right, because as you know, water in Malaysia is a state matter, so it's owned by the state water operators. Like in Selangor, it will be under Selangor. So these water authorities, they are at different levels of digital maturity, actually. So some are more advanced, the bigger states are more advanced, and some are trying to
Losing Miss Anna.
Yeah, I think so. Okay, Miss Anne, you're lagging a little bit. Let's take some time. We can't hear you as well as your video is not running. Okay, perhaps you can sign out. You can sign out and then you sign in again. Maybe the internet might work. Yeah, we can see your video moving, so you just have to unmute now.
Sorry. Okay.
Yeah.
I have some internet interruption just now. Sorry. Okay. Let me start again with the answer. So water in Malaysia is state-owned. So in some of the water operators, in some of the more advanced states, or the more the more advanced state, they are more matured when it comes to digitalization, and the rest of the states are trying to catch up. But nevertheless, they are moving towards IR 4.0. So Hsion is actually our Endress+Hauser IIoT ecosystem. They do not subscribe to Hsion yet. We did promote to them, but they have the more advanced state. They have their own in their own cloud solution already. So for example, like IChemE, they have what they call a command center. So their assets remotely are all actually, the idea is to connect all their important assets back to a remote, back to a command center, which is centralized, so that from one center, they can have the overview of all the water operation plants, the distribution, networking, up to the reservoir, the storage to the customers. So for us, when it comes to Hsion, what we can have is also to have third party, for example, like the weather forecast embedded into this particular cloud as well. So we can actually link a weather forecast, and from the weather forecast, you can actually do a prediction whether there will be whether there will be rain or not in the next couple of weeks. So as you know, water industry is a very challenging industry because they cannot control their supply. It is not like other manufacturing plants. If I anticipate my demand next week is this much, I can actually top up my supply to increase up my production. But water is a very unique one because their supply is depending on the weather. So if we are having a drought, if we are having a hot season, the consumption will increase because people will utilize water more because it's very hot. Okay, they don't have rain. You wash your car with the water supply and so on and so forth. The utilization of water is high, but the supply is low. So we can have AI actually based on the past history and patterns and modeling to actually to tell these water operators what will be the expected consumption be in the next coming weeks, for example, forecasting. And then from the weather forecast, we can actually tell the water operators whether they can anticipate rain or not. So from there, they can actually do their planning when it comes to uninterrupted supply to the consumers. So the more advanced one, what I know is that their pipings are a bit flexible. They can actually channel pipes from other resources to actually supply to the areas where they have a shortage in supply. So the water industry is actually moving towards IR 4.0. Okay.
Right. Okay. So yeah, Oscar has something to say. The basic of IR 4.0 is internet accessibility. If we don't have internet accessibility, especially in rural areas, then can we still use the IR 4.0 devices?
Okay, it's a very interesting question because if you remember the first chart I showed just now is connectivity. In order to have IR 4.0, we need data to be feedback from the physical layer, that means at the ground layer. Okay, if we do not have connectivity, especially in the rural area, then we have to look at ways and means to have this connectivity established. So there are optionals like they call this LoRaWAN technology, okay, where they are apply in those areas where you have poor connectivity. But then if you really do not have any other ways of connectivity, then you cannot use, you cannot implement this digitalization or IR 4.0 because the data still remains at the site. There's no way you can actually transfer back this data to a central location. So if that is the case, then you cannot have, if you cannot have connectivity, then in short, you cannot implement Industrial 4.0. That's it. In order to implement smart industry or IR 4.0, connectivity is the key. So first of all, you need to have the connectivity. But nevertheless, I heard that the government now is pushing into implementing connectivity, right? 5G. So in time to come, when the whole of Malaysia is covered with this connectivity, then I'm sure we will be able to achieve what we want to achieve with IR 4.0. Yeah.
Right. Okay. So connectivity. Right. So if we want it to be automated, we want to make it high end, then we have to base the fundamental issue, which is the connectivity, right? All right, so again, so we have another question for Dr. Lim. Dr. Lim, why do many stakeholders not want to implement new tech industry? If you present your ROI chart or calculation to industrial players, let's say Miss N and IR Zulfan, does it help to convince them? So I think this one, first, Dr. Lim will answer why do many not want to implement, and can you convince? And IR Zulfan and Miss N, maybe you can attest whether you're convinced or not.
Okay, the first part on why many stakeholders don't reluctant to have a new technology. My take in the researcher or academic point of view is the mindset. Okay, like I think we kind of mentioned earlier that a lot of these, I think engineers so far mentioned Southeast Asia, Asia. A lot of time we just try to adapt whatever technologies has been matured because we do not have the R&D center and we do it ourselves, prove it ourselves. So this is the first thing, the mindset of the stakeholders in our region. Usually just try that instead of develop. But this actually can go back to the, for example, the ROI chart and things that I have done. Basically, the idea is that in order to convince the owner to adapt new things, they are always talking about business. So they are doing business, talking about money. So ROI is the first thing that I truly believe that we have to show. Okay? I'm not saying that showing the ROI, they will 100% on board, but at least this gives us the chance to tell them, if you invest into this thing, what is the expected return? And being the academic and also researcher, I believe we have this kind of unique position in the way that we are the one that doing this to convince the industry, in the local industry of Malaysia, right? Doing a local case study to show that even we implement in Malaysia, this is at least something that can expect, for example, the ROI, or we can reduce the carbon footprint if the company are willing to go for this sustainability development, etc. So we are the one that trying to quantify it. But if we don't do that, they will never be, they won't take a first step to go forward to say, they won't suddenly in the morning say, let's try Internet of Things, without knowing these values or this number. So I would say that, this is the first step. And I believe, I heard Zulfan and Ms. N, I think will believe, I'm not sure if you approach your customer, definitely they will ask, how much I can get back if I start to invest into your company technology. Yeah. Hopefully, I think my value might not be convinced them directly. And I think the point is, a lot of these industrial 4 technology, my perspective is it's always a unique solution. Okay? We can't do a general ROI to say that I out 4 will give you 10%. It doesn't work that way. We have to say, okay, if you implement in water and to predict the water, water supply and also the management things, this is not one type of application. How much is the ROI? If you go for other things, just IoT, the data management or analysis, different application, that will give you different ROI. So that's why we need to systematically evaluate the different application one by one, and then we show the chart, a different chart, the comparison with the existing the technology to convince the stakeholders. Yeah.
Okay. So IR Zulfan and Miss Anne, are you convinced? Or will you be convinced? Or what it takes you to convince?
Actually, I agree with what Dr. Lim says. every time when we go to the big bosses, the first question they ask, what is the value I can get out of it? What will be the break-even time? When can I get back my money? So for us, we have very simple calculation every time when we ask the customer to upgrade, let's say from a mechanical to a more sophisticated system. So we always have this simple calculation to show to the customer, like what Dr. Lim mentioned. So actually coming back to IR 4.0, if you ask my opinion, I would say that I believe majority of the management, they agree that this is the way to go. Okay, there is no escape and it is not an option. So they have to embrace this change. So now the question is when and how? So when should I start this journey and how? So for me, IR 4.0 or smart industry, this is a journey. I cannot it's a transformation. That means it's evolving. So I cannot change overnight from a very, I would say, a physical factory. Suddenly everything is so high tech and digitalized overnight. So where should I start? And all this, the readiness, we have to evaluate. And as I know, the government have this, they have this, what do you call this, by, I think MIDA or MIDA, they have this program where they have this specialist consultant to come to, if you call them, they will come and tell you and do an evaluation to tell you how ready you are, as an organization to embark into IR 4.0. So I always tell the customer, first of all, you must understand where is your critical pain, what you want to achieve out of this journey, like what Dr. Lim mentioned. And then from there, you start from one small area, and then you expand to a bigger area. And then at the end of the day, you have everything integrated together. So I have not seen one company overnight, they say, okay, change everything and we move from this to IR 4.0. It is always a transformation journey. They always start from where the source of the problem is, where they see the highest return of investment, or where they see there is a major need to transform and change. They always start from that particular area first. So, and also the other thing, the other challenge is the people. So once the company says, okay, let's go for digitalization, and they start to plan everything digitally and transformation, the other thing is the mindset of the people, the mindset of the people. Because you are transforming the way they work, you no longer need to touch the pipe. You have to hold an iPad, and you no longer bring your wires and cables to test what is wrong. You have to know how to read it wirelessly or digitally from smart kind of process kind of troubleshooting. If you do not have this skill, I tell you, you'll be scared. You can no longer go down with your multimeters. So the readiness of the people, and then you need to actually reskill these people, retrain these people, and you need to bring the whole organization on board. It is not just like investing into changing your instrumentation or changing your equipments and buy robotics, put in machines. It's also the change to bring the people along into this journey. So this is also very important. Yeah, I always tell my customers, start small and then you scale up. That is, and that will lower down your risk because you are starting it from the small area. Yeah.
Right. Okay. Thank you. Yeah. Thank you, Ms. Anne. So we're having more questions coming in. So we're going to take turns to answer. So the next question is that we seem to touch less in the aspects of environmental sustainability. Is smart industry essentially a greener industry? For example, use of blockchain technology have caused some environmental concerns. What's the take from the panel? So anyone could pick that up. No? I think Miss.
Maybe I'll go for it. Yeah. Yeah, I do agree that the environmental and the sustainability aspect is one of the key things that we cannot ignore. And that's one of the reasons why one of my study actually included is one of the criteria. But nonetheless, although it's important to highlight But I think at this point, looking at the state, especially in Malaysia and our country, I think we have to break through the first barrier of disorder, which is money-wise first. If money-wise and sustainability and environment will be a bit difficult, although they have, they should also involve or look into this. There are some companies actually looking at that, but I think we have to look at these questions or this problem concurrently. Okay? And looking at like blockchain that could cause environmental concern, I'm not sure like which specific concern that the participant addressed, but I do know that there's some problem with blockchains. For example, like the size of the data will getting bigger and bigger, etc. Then it will create a data storage problem, transaction problem, etc. But what we can do is perhaps, again, this is something more on process integration where we look into alternative of the green technology such as solar panels and etc. as part of the solution. So we can sell it as a package. So instead of using a conventional electricity as a supply, okay, we can use solar panel or other alternative resources. I'm not hopefully the industry are going towards that direction. Okay, but that is
I think we should definitely include, because it's a mathematical model, so it could be one of our components that we pay attention to the environment and sustainability.
Yes, we definitely, in terms of modeling, we can do various like multi-objective consideration, etc. Again, that is provided that the industry will have the solution for that. Well, if let's say the industry do not have a green solution, the model that we have, we can't actually do much, but there's no physically technology are there. There's some tips that we can integrate multiple like green technologies into the IR4 technologies as one whole package, and hopefully that will sell this technology in economy and social and also environmental aspect.
Yeah, true, totally agree. So we have more questions coming in, and we also have a question posted on our Mentimeter by our participants. So probably can I have the team to share the questions on screen? Wow, okay, that's a lot.
Wow.
We have two more questions here on the chat panel as well. Right, so we will look into this Mentimeter before we get back to the chat panel again. Right, okay, so they picked something for you. You talked, yeah.
Okay. So actually this one is actually coming back to connectivity. Okay, it's still coming back to connectivity because the technology is there. But then if you do not have the connectivity, then it defeats the purpose. But I believe, that, if the truck is sending chemicals to those areas, and those areas should be in the industrial zone. So the GPS or the connectivity, I believe, should be there, unlike the water industry where we are talking about, where you have very rural area, the very Kawasan Pendalaman, very rural area. But then if we are talking about sending trucks of chemicals into industry zone, I believe they would have good GPS coverage. But then coming back to this is that for us from the industry, we can only provide instruments which is equipped with this. And then, but then if the telco or the connectivity is not there, then we will have to wait until Malaysia is matured before we can adopt this solution. That is what I can comment actually.
I think this has been elaborated just now.
Yeah.
Can I check for this technology, is it possible that the sensors or the device can have a data log, data logging kind of like function? So as they move in the rural area, they continuously to log the system, and as they go back to the the area with internet, then they can just kind of sync.
Yes. If during that time there is loss in connectivity, of course, then later when the connectivity is back, then they can actually upload again. Anyway, it is not online. That means it is on periodic basis. So you can set the timing where you want to send the data up, because there's no need for online anyway, because the consumption or the level of movement is not that fast. Yeah.
Right. Okay. Right. Can the main question? Can I see all the questions? Yeah. Okay. Let me choose the question because some of it has already been answered and you have quite a lot. Right. Do you see? Since I can't control. Okay, let's see this one. Can you comment on the role of blockchain? So I see 2 blockchain questions. Okay, there was another blockchain questions above, right? This one, blockchain and metaverse seems to be a hot buzz these days. This technology plays important role in chemical engineering industry. Yeah, this is something interesting. So anybody would like to pick up this question? Yeah, probably the admin, can you also highlight the, can we also look into the other question on blockchain? The other question on blockchain. Can you comment on the role of blockchain technology? So it's the same. So, okay, this one is palm oil industry. What are the pros and cons? So literally, so I think basically to summarize it in chemical engineering, how important is blockchain and metaverse?
So maybe for this, the blockchain, my take is that blockchain, what I understand is it started from this kind of the transaction, right? To be secure transactions point of view, it developed from there. And as the times go, then we start to go into these traceability issues problem. Because it's a secure kind of like model or framework, which require, there's a lot of these niche or these, the technical spec of that. Basically, someone have to verify, multiple identity have to verify the transactions so that it can be hacked, basically. Okay? But my take on this is that before we go into this blockchain technology, we have to first kind of like understand how critical is this data security or this cyber security that we are talking about. If we are just looking at the data monitoring or like some of these process data monitoring, okay, I believe we may not need to deploy such a blockchain technology. But from what I understand for this industry, they deploy this blockchain is about the traceability, because the issues on this sustainable palm oil production, like the MSPO, RSPO things, so they need to kind of like prove source of these the oil or the free, basically the bunches or the mills, okay, to determine whether they are a sustainable certified producer or not, okay, the palm oil sustainable palm oil producer. So this is one way that blockchain technology can be beneficial. But of course, I believe that in terms of cybersecurity and the traceability, blockchain is not the only solution, I would say. But it's one of the solutions. But there are other things that, or there are other approaches we can do. If let's say blockchains is something that other company or other industry are not looking into.
Okay. Right. Okay. Right. Thank you, Dr. Lim. Right. If anybody wants to add, you can add. Otherwise, I can move on to another question since we have lots of them. Right. Okay. I move on. Okay. But anytime, please do interrupt me if you want to add in. Yeah. Right. So this one, a question on cybersecurity, because I see it on the chat panel as well. Right. So the concern here is that it's a lot to do with data security. So is the current security in place is sufficient to protect the important data? And that's the question on the chat. And then on this Mentimeter, who controls and monitors the data? US, Switzerland, or Malaysia, ourselves centralize the data? How well regulated in Malaysia? So I can summarize that we are concerned about data. Right. Yes. Yes, Mithili.
Okay, on cyber security, actually, this is a very, very hot topic when we talk about IIoT. You know, customer is afraid that, their data is being being hacked. Okay, or someone can actually go into, for example, if you have the controls and someone can actually hack into the control and do something funny into your control system, and then your whole plant will be jeopardized. So for Malaysia at this moment, what I understand is that Jabatan Standard Malaysia, the Malaysian standard, they are actually looking into this, and there is a working group. And we are also, Endress+Hauser, we are part of the member of the working group. And we are looking into adopting this standard called IEC 62443, okay, to be legislated and also to be followed in Malaysia. So at the present moment, what I understand is that a lot of the companies, it is out of their own initiative, or if they are actually a multinational company, they actually follow the parent company or the HQ. When it comes to adoption of digitalization in the local company. For Malaysia itself, we are trying to legislate so that the industry actually follows and adopt IEC 62443. Actually, this initiative is actually led by also or pushed or supported also by our Petronas. So there is a working group working on it, but then we have not come into finalization. So there's still a lot of workshop and still a lot of feedback from the industry. So this is what I can, for us, from being a Swiss company, of course, we have those, we follow those ISO and IEC standards when it comes to data security or cyber security for process automation. We have those certs already approved. But then in Malaysia, still we have to follow the Malaysian standard, and we are looking into this at this present moment. That is what I know. I'm not sure about the other panelists. Maybe they can comment. Yeah.
So at present we are out. We're actually bare out there. So we are still vulnerable. We're not fully protected. So we're still busy tapping into IR Corp. Yeah.
So this could be one of the drawback, even though Dr. Lim shows them that they have a good ROI, then this could be also a drawback why the management doesn't want to invest.
There you go. So we got an answer. All right. Okay. Other panels wants to add?
Maybe I just want to highlight about the blockchain or the cybersecurity earlier. From my understanding is that a blockchain, we do have kind of different structure, like can be a public blockchain, can be a private blockchain. So I think like in the case that the companies are worried on this the cybersecurity, of course they can go with a smaller scale, go for the private first, and then they can establish their own multiple server. I mean, all the servers are still under control by the company. It's just that it creates another layer of protection in the sense that all the servers have to be hacked together to basically hack the system. Put it this way, so they can still do a private blockchain system or framework if they want. So at least you get the blockchain level of kind of security, but everything is still managed by the company itself.
I'll add something on this because these terms, they appear often. Myself, I'm not really familiar with blockchain other than knowing that blockchain is like simple, or not simple, it's just like the transfer of knowledge, which is very secured. Well, in companies, they do have different layers of security. So different types of information, only certain type of people can access to it. So we have to, for example, if you want to access a project somewhere in US or somewhere in Brazil, we have to be given clearance on how to get access to that, and it has to go like to several layers. So it's not that everybody, even though they are in the same company, they can have access to all information. That's not the case. So I'm not really sure if that's answering the questions on the blockchain, but on the other hand, the metaverse, this is also quite interesting. In chemical industries or in process industries, we have what we call, which I think quite similar with metaverse, yeah. We have what we call like operator training simulator, so OTS. So if the students, they know about this flight simulator, So before the pilots can fly a plane, they also have to go these hours and hours of flight simulator training. So in chemical industries as well, nowadays, before the operators are allowed to operate the plant, they have to undergo days of operator training simulators, where we have the simulation model of the plant, the digital twin, if you would like it. And then the experienced engineers will then show how to operate the plant virtually, and then they will then also include some anomalies during the operations, and they will then evaluate the response of the trained operators. If the operators pass the test, and then they will then be allowed to operate the plant physically. So it's more like this virtual environment that we can see and what is happening in the plant without actually opening a valve somewhere in the plant. Yeah. So this technology on the operator training simulation is now it's getting more and more complicated, including this metaverse. So this what we call like augmented reality, DAR, and also the virtual reality. So all of these OTS are now, not all, but then some of the OTS providers, they come with this add-on experience, so that the operators really can feel how to walk and then how to go up the stairs and so on and so forth. So there is a certain technology.
Right. Okay. Right. Thank you. Right. I have a question here, but which I don't understand myself, so I just want to know if the panelists know it. Is smart industry smart enough to handle black swan incident? Have you heard of it? Do you know what it is?
Yeah.
Yeah, if you know, probably you can explain it to us. I have no idea about it. If we don't know, skip this.
Well, let me start first. Yeah. COVID-19 is our black swan incident. So it's we call it black swans because we know that there is no such a thing as black swans. There's also white swan. And then this one incident that just appeared out of nowhere, and then it has no like a precursor or something that we could predict. So that's what we call black swan. So COVID-19 is a black swan. And then recently in the couple of years, because of this COVID-19, we have also like a lower capacity to produce fuels, and then also lower demand. And this is what we call like a gray rhino effect as well. So these two terms are interlinked together. Answering this question whether smart industry is smart enough to handle black swan incidents, I think we all know already what the answer is. No, it is no, because well, we cannot predict that COVID came in 2020. So I would need to emphasize here, yeah, smart industry or something can be called smart, not only because of the technologies are there. I think Ms. Ant emphasized this already a few times. I'll just reiterate that. So to have a smart industries or smart technologies in implementation, we have to have smart people first. So without smart people, there is no such thing as smart industries. Yeah, it's also like it's only like a gadget. I mean, we could have a smartphone, but if what we have in a smartphone is just on like TikTok or Instagram or I don't know, so that doesn't make the use of that smartphone is not going to be very useful, right? We have to have a smart people controlling what's in the smartphone so that that he or she can use that smartphone or smart digital to make them better. So we need to have that first. Without having that, it's impossible to do anything, any improvement. And also even we were not going to be able to predict this black swan incident.
All right. So now I know black swan. Yeah, Miss Anne, do you want to say something?
I think I have already emphasized quite a fair bit, you know, that digitalization or IR 4.0 or smart industry is based on massive of data, how you interpret the data and how you actually make use of the mathematical modeling and artificial intelligence to get your desired output. So it is based on data. It is based on data analysis. So we cannot anticipate, or we are not prepared. The smart industry is not prepared to react into something which is unprecedented or not, what do you call this, considered at all in the data. So all this, like the example I give on the water industry prediction, these are all based on past data consumption, how the water is being used, the pattern, you know, and so on and so forth. But if there is a black swan which we did not anticipate, then the digitalization of the industry is that is where the human makes a difference, like what engineer Zulfan said. That is where we need our creativity, our intelligence in resolving this kind of incidents, you know, that's where we add value into it, and not the smart industry or not the AI or robotics anymore. Yeah.
Fabulous. Okay, that just reinstates that people is still important.
Yes.
Okay, so now I know what is black swan incident, but black swan exists in Perth. So you can find black swan in Perth. Probably it's rare, and then you just see it by chance. Right. Okay. So we should end our forum at 9:15. So I've looked through most of the questions. At most, we probably have another 2 to address. So I'm going to choose between. I think I'm going to choose the one in the chat first, which I think is an interesting question. So although it's directed to Miss N, I think all of us can give an input. Miss N, many students think that working in IR4 is clean. Do you agree with them? Being the only female industrial panelist here, does your company have any incentive to encourage women participation in industry? So literally it's about participation of women in industry and what are the incentives we get. So I think everyone can actually answer, but we can start with Miss Anne first.
Okay. Actually, our companies encourage women participation in the engineering industry. So if you have a chance to visit our company, you'll be surprised to see how many women we have in our company, and they are all, most of them, you know, besides the supporting staff, most of them are engineer by profession. You know, somehow they have a technology or a technical background in engineering. So you can see them in the project department. Last time we also used to have engineers in the service, so they actually go out to different plants to service the customers. So to me, women participation, especially in technology or in engineering per se in Malaysia, I would say it is getting, the acceptance level is getting higher and higher. So I remember when I first joined the industry, of course, being a female engineer, when you walk into the plant, there'll be a lot of eyes looking at you. But then today it is very common to have female engineers, and even to the extent of at the offshore, you know, even in the oil and gas, in the offshore. So they are equal. I would say women are equivalently good when it comes to technical background. Yeah. So I do not really understand the first question, which is clean. When you say clean, that means we do not need to get our hands dirty. Is that what you mean?
I think so. I think that's what you mean.
Okay. I would say that, of course, maybe this particular student have this impression from the picture which I showed just now, you know, that you can stand with your iPad. You do not need to go there to connect to the instruments. Yeah, but of course, I mean, sometimes it boils down to basics. When technology fails us, sometimes you need to still go back to basics. Of course, today the connectivity is there, you know, the technology is there to assist us. But nevertheless, you know, sometimes if technology fails us, where there is no connectivity, then there is where the experience comes in. Of course, today it is much better compared to those days, but then I would not say that it is 100% clean, that you do not need to touch the device at all. So if the device fails, you still need to maybe open up and look at it because today still a lot is wired, and they have not moved into the wireless technology, because the wireless technology today is still used, for example, only for monitoring, not for process plant control. So if it is for process plant control, it is still wired. So if it is still wired, you still need to go there and open up the device, you know, to check on the wiring if something is wrong. Okay, so I will not say 100% clean. You still need to get your hands into the device. Yeah.
Right. Yeah. Fabulous. Fabulous. Yeah. So, anyone wants to add?
Well, I've heard some discussions on this IoT, whether we can implement them in chemical plants or in refinery or in process plants. So the notion that I got at the time is that we have, I mean, the internet connection is not that stable. I don't know whether we can achieve like a perfect stability in the near future or not. That one I don't know. But then because of this instability, well, I don't think we would then say, for example, I want to open the valve here in the control room, and then with that internet connection, that the valve on the field will open or close automatically if there is something wrong in the connection. So so the discussion at the time was more like we would stick to this cable, right, that Ms. Anne mentioned, which we have to also connect and bring them to the field. So yeah, I just want to add that into this clean, so to say, stuff.
All right. Okay. Okay. That's interesting. Right. Okay. So I think it's 9:13 now. I should be wrapping up. Before that, I have something a little compelling, maybe something useful for the students. This will be our last question. So they are concerned, they are interested in overseas, right? So one question is about how is Indonesia, this is for IR Zulfan, how is Indonesia industry different from Malaysia, if you've been in Indonesia's industry, and how do we gear up ourselves if we want to step into foreign countries? So to just summarize both of this, if our students want to step into foreign countries, how do they prepare themselves?
Okay, interesting. I think to be honest, I will have to disappoint the questioner here. I have only like less than a year of experience working in Indonesia, so that's my my honest feedback. Less than a year, so it's there's nothing that I can tell about the experience as process engineer in Indonesia. About the industry, how different it is from Malaysia. Like it has been mentioned before, different types of industries, even the same industries at different regions, we have there are different level of maturities in technologies, and hence different IR, right? So it's still IR is 0.0 even if we know what it is. So there are things like that. What is, I mean, the striking difference between Malaysia and Indonesia is that the demography, I mean, the islands we have Indonesia, they are archipelago, so the infrastructure is quite challenging over there. So and then also the transportation side is also then from that perspective is also very challenging, yeah, especially if we look from the supply chain perspective. So that also how to call it, that also affects the progress of the technologies and industries in Indonesia as compared to what we have or what you guys have in Malaysia. I cannot say any more detail than that because I have no experience, or I mean, less than a year experience working in Indonesia. So that's on that question. So really sorry. And then how do we gear up ourselves if we want to step into foreign countries? I just want to iterate what has been mentioned before. Wherever we are, regardless whether we are in our home country or in a foreign country, people value skills. So with that skills, we don't really care what kind of skills, whether it's engineering skills or cooking skills, communication skills, all kinds of skills that are really beneficial to help other people. That is something that we have to gear ourselves up. So while in this perspective, we are talking from the chemical engineering perspective, obviously that kind of skill is the chemical engineering skills. And also along with the current buzzwords that we have to have, like this data analytical skills, communication skills, and then the a little bit of programming skills. If we can have that kind of basics strong, I think it's just a matter of time that we will be working in a different country.
Right. Okay. Yeah. Other panels, would you like to add?
Maybe I can share a little bit. I have not worked in Indonesia, but I have done some projects for Indonesian customers. So I can say that if you are looking into working in Indonesia, one of the industry which you can consider will be palm oil, because for palm oil, Malaysia is the hub, for palm oil industry. So the engineering companies, the plant builders, they are all in Malaysia. So the Indonesia companies actually come to the Malaysian companies to actually buy plants or engineering or consultant over here. So the engineering, the consultancy, and the plant builders are here in Malaysia. So they actually build plants for Indonesia customers. So one of it you can consider is maybe to embark into palm oil industry or to work in this kind of plant builders. But I have to agree with what engineer Zulfan mentioned just now. In any countries, people value skills. You have to be skillful in what you do before you can get into a company or even a country. That is my advice. Yeah.
Maybe I just want to quick add on that. Apart from the skills, and I also believe that you need to know how to present yourself in the audience. So it's very clear that, for example, if you're doing your final year projects or one design, etc., you have the presentations. Right? The presentation will shows you weren't able to show how much you're doing. But you have to show to us that these are the things that you involve, these are the things that you have done a lot of calculations and etc. to tell us that you are the one that actually do the work. So if you don't present yourself well, no matter how much you have done, the audience or maybe the industry will not know what's the skills are basically. So yeah, skills are important. So but you have to be confident that you know the skill and present yourself to everyone.
Right. Okay. That's that. Thank you. Yeah. That's important. As well as I also would like to add up. So we have 3 bodies governing engineers in Malaysia. Yeah. So first one is the Board of Engineers Malaysia. So once you have graduated, you should register yourself in Board of Engineers Malaysia. So that is actually a regulation for you to be legally serving in Malaysia as an engineer. And the BEM has also have connections for you to work in ASEAN countries. And then we also have IChemE, right? They're also our the quiz sponsors for this forum. So IChemE is affiliated to UK, so you can also be their member, and then you're open to working in a wider scope, even in UK. Right, and we also have IEM, Institutions of Engineers Malaysia, who also works with from other country, which also broadens your networks to other countries and also other engineers. Right? Okay. We are 5 minutes past the time that was given to us. So with that, we can conclude our forum today. So the participants, you stay tuned still. Because there's going to be a quiz session. So we're going to have a few quiz, and then we have winners. When it's the winning, I think the winners gets prize money, if I'm not mistaken, and quite a number of prizes, 10 prizes, if I'm not mistaken. So so you'll get more details from the admins when I pass it to them. So before I end, I would like to thank IR Dr. Lim, IR Zulfan, and Miss Anne for your time with us here in our CEUC. Thank you very much.
Thank you.
Thank you. Thank you for having me.
Most welcome. So I pass over to the admin. So for the panels, it's optional. You can stay on for the quiz if you want to, but you can leave after this session ends as well. It's entirely up to you. passing over to the MC, Aaron.
All right. Thank you, Dr. Jega. Thank you once again, IR Dr. Jega as a moderator, and also our fellow panelists tonight, IR Dr. Lim Chun Hsion, IR Zulfan Adi Putra, as well as Miss Anne Lim Mei Liang. I would say it was indeed an interesting and instructive forum discussion, and we truly gained a lot from the forum discussion just now. Before we end the event, I would like to invite all of you to turn on your camera for a photography session together with our panelists.
Ladies and gentlemen, please be patient while waiting for everyone to turn on their camera for photography session. Okay, I believe everyone has switched on the camera, so I'll take the photo now. So on my count, 1, 2, 3. One more, 1, 2, 3. Thank you.
Thank you, everyone. And with this, our forum session has come to an end. Once again, thanks to our panelists for sharing your wisdom and experience with us tonight. We truly appreciate it, and I hope everyone enjoyed and benefited from the forum discussion. Our next session will be a Kahoot session, and without further ado, I would like to invite Devin to moderate this session together with me. May you, Devin?
Yes, of course, Aaron. Hi, everyone. I'm back. My name is Devin.
And once again, my name is Aaron. We will be the moderators for this Kahoot session, and we welcome you all to this session.
Dear participants, now before we move on, here are a few reminders. Firstly, kindly proceed to www.kahoot.com and key in the game pin 800713. I repeat, 800713 to join our Kahoot session, or you may just click the link provided in the chat box. And secondly, upon joining the Kahoot, please rename yourself with your full name for the ease of identification of winners.
Yes, Devin, we will basically be asking 11 questions regarding our forum discussion earlier. And now, for the most exciting part of this challenge, the prize pool of this Kahoot session. For your information, we'll be giving out cash prizes of a total of 810 ringgit as our prize pool. The first winner will get 80 ringgit, the second winner will get 70 ringgit, while the third winner will get 60 ringgit.
And the fourth until the 15th winner will get 50 ringgit respectively. Sounds interesting, right, Aaron?
Yes, David, that is a lot of money. Sounds very attractive and exciting. Don't you feel the same, dear participants? Come and join us to grab these amazing prizes.
That is right. Dear participants, come and join us. Now we'll wait for a while until most of the participants join the Kahoot. And please be reminded that to use your full name as your Kahoot username for the ease of identification of winners. Thank you. Come and join us. The game pin is 800713. I repeat, 800713. And make sure to rename yourself appropriately.
Don't be shy, guys.
So as for now, we have 13 participants, 14 now, and I'm sure there's more. Come and join us.
The questions won't be that difficult, and it's a great way to earn a bit of pocket money.
Come and join us. The game pin is 800713. I'll repeat 800713. So you may just join our Kahoot by clicking on the link provided in the chat box. And please be reminded that to use your full name as your Kahoot username for the ease of identification of winners. Come and win the cash prizes. Don't be shy. We won't be asking difficult questions. Right, is there more? I think we shall start, Aaron, shall we?
All right, now I believe most of the participants who are interested have joined our Kahoot. So I think we shall start our Kahoot now. Let's go. For the first question, Industry 4 increases operational efficiency. Which of these four themes presented do not summarize Industry 4.0? The correct answer is information ambiguity. Moving on to the next question.
Right, let's see the second question. Now, with the rapid development of the smart industry, what are the industry expectations from the young engineers in regards to Industry 4.0 knowledge or skill? Which one do you think? Yes, the correct answer is interdisciplinary knowledge, technical and management skills. And let's see who is leading. Congratulations, Farah. You're leading now. And let's proceed with the next question.
For the third question, which of these major components are not used to define the term Industry 4.0 or Smart Industry? Correct answer is technoware. Congratulations to Wang Wei Han for taking the first spot for now.
And let us proceed. The next question. Which job nature is at the highest risk of being redundant or obsolete in smart industry? Which one do you think? Yes, it's indeed the routine and repetitive. Congratulations to Wong Wei Han. You're still leading now. And let us proceed.
On to the fifth question. Which of the statements is false? I'll leave it to you to read them. Congratulations to most of you who got it right. Now it seems that Nadia have overtaken Wang Wei Han. Congratulations.
And let us proceed. And now in the sixth question, which are not the challenges for the palm oil industry? Congratulations to those who make it right. And let's see who is still leading. Congratulations to Wong Wei Han. You are having a streak now with 6 correct answers in a row.
For the seventh question, which palm oil plant is most advanced in terms of degree of automation? Mill, kernel crushing, refinery, or oleochemical? Well done to the ones who got it right. The answer is oleochemical. Well done to Farah Adina as well.
And let us proceed to the next question. What was the approach used by engineer Dr. Liang and his team to evaluate the IR4 implementation gaps in palm oil industry? Which one do you think? Yes, congratulations to those who make it correct. And let's see. Congratulations to Wong Wei Han once again, and let us proceed.
For the ninth question, which of the following is not considered as IR4 revolution? Remember, the keyword is not, so we might want to be careful. Congrats to the winners, or the ones who got it right. Oh, Wei Han's still in the lead. Well done.
And let us proceed with the last second question. Which of the following statement is true? Which one is true? So the correct answer should be recording data digitally is crucial for IR4. Let us proceed.
For our final question of the day is, how can palm oil industry be beneficial from IR4 implementation? Reduce labor dependency, improve product traceability, effective fruit monitoring and harvesting, or all of the above? Well done, everyone. Our Kahoot session has come to an end. Now let us see who our winners are for today.
All right,
In third
let us
place,
see.
we've got Lim Jun Yong.
Now the
And
second place goes to Farah.
And
the
for our
first place-
champion, we have Wang Wei
Yes.
Han. Congratulations, everyone, to all the winners and the runner-ups as well.
Congratulations once again to all winners, and to all winners, kindly take note that our technician team will approach you soon for the giving of prizes. And for the 4th until 15th winners, we will be announcing the full winner name list during our official winner announcement and closing ceremony tomorrow. And we'll be posting your names afterwards on our social media pages. So kindly follow us on Facebook and Instagram by clicking on the links provided in the chat box.
Yeah, congratulations once again to all winners. Dear participants, thank you for participating in the Kahoot session.
Dear participants, and that is the end of the Kahoot session. Thank you very much for your participation once again, and we hope that you had fun. And with these, we shall call it a day for the first day of our event now.
Yes, Devin, finally we have come to an end for the first day of our event, and hereby on behalf of the Organizing Committee Board of our CEUC 2022, we would like to once again thank you for staying with us until the end of today's sessions.
Dear participants, kindly be reminded that the second day of our event is tomorrow, and we'll start at 9 a.m. sharp. So for tomorrow, we will be having keynote speeches with the titles of Reimagining Plantation and Stretching the Limits of Industrial Water Savings, respectively, prototype demonstration competition, and the final round of the online presentation. It sounds exciting, right? So on behalf of the Organizing Committee Board of our CEUC 2022, it is much appreciated if everyone can attend the second day of our event on time, and we do look forward to seeing your faces again tomorrow. Thank you once again for your participation today, and see you tomorrow. Good night.
Have a good night, everyone.